Okay, I will also want to start the lesson now. So I will quickly go through, some of the revision. So that means I will run through what I have covered previously because some of you have not done this topic yet. So let me know when you can see my screen. Okay, if you can see my screen, it says magnetic attraction, filtration, and evaporation. Can you see my screen? If you can, put out your hand. Yeah. Okay, good. Yes. Lohita, I can see your emoticon now. That's good. All right. So let me very quickly run through what I have taught previously. Okay, this is for the advantage of those who have not covered this lesson. All right. So this particular topic, firstly, you have already learned about mixtures and pure substances. So that means you know elements, compounds, and mixtures, right? Okay, so you know the definition of mixtures is made up of two or more substances that are not chemically combined together. So these are the important words. They are in purple. Okay, so you have to take note. These are the important words, right? So when you define mixtures, this is how you write it down. Okay, so we know examples of mixtures already. There are so many of them. Pure substances, it can be either a single element. What are elements? You find elements in the periodic table. Yeah, so you have already covered the periodic table as well. You need to know how the periodic table looks like and how to locate the elements in the periodic table. Okay, and then compounds. Okay, so these are the pure substances, elements or compounds. So they are not mixed with any other substance. This is diamond. Diamond is made of carbon. Okay, carbon is found in the periodic table. Okay. Now, so the first part to the separation, some of you will be familiar already because you have done this or you have gone through the lessons with me last lesson. So magnetic attraction is one way we actually separate mixtures. Okay, it's only for those mixtures that contain substances that are attracted by magnets. All right, so in this particular example, you see the diagram here, right? Okay, so the iron filings, some of you pronounce as iron filings, it's okay. Now, because iron itself is a magnetic material, you are familiar because you have already studied this in primary school. You have done magnets, the topic on magnets in P4. Okay, so you know that being a magnetic material, it will be attracted by the magnet. Okay, so in this case, the moment I put a magnet at the top of this mixture, the iron filings will be attracted. Okay, you can stop me or raise your hand if you have questions. Another way of asking me questions is to type into the chat. Then I can see it. I'll respond when there is time. But I will definitely address all the questions you type into the chat. Yeah. So if you don't want to disrupt the lesson, not that urgent, just type your question in and then I will address the questions. In some parts of the lesson. Okay, so these are the examples. Okay, filtration is another method. All right. So what is filtration? Filtration is a method used to separate insoluble particles from a liquid. Right? So in filtration, we make use of filter funnel, and then we also make use of filter paper. So these are the essential ones. What are the mixtures that we separate using filtration? Sand and water, chalk powder and water. You learn suspension and solution already, right? Yes or no? You should have by this time. So what solution, what suspension? I don't think I need to go through. If you cannot remember, quickly after today's lesson, go and read up on your notes, or read your textbook. So what's the meaning of suspension? It's actually a mixture where there are solid particles found throughout the liquid. Don't have to copy the notes, all right? I will provide you with the notes, either end of the lesson or the next lesson. That means at the beginning of next lesson, I will send you the notes. In PDF form, right? You can take quick notes here and there, but don't have to copy all the words here. All right, I will always provide you with the notes from now on. because the notes are getting longer and longer, not like the earlier topics is a lot easier. Okay. Now, so what is the principle behind filtration? Okay, in the filter paper, you might not see it, but if you were to magnify it a lot of times, you can see the gaps. All right, so this is actually the filter paper. And this is what is happening now after you pour the mixture through it. Only the small particles like water, so water particles are very small. They can pass through the filter paper, but this is actually the sand particles, too big. So they are too big, they cannot pass through the holes in the filter paper. Clear? All right, so this is basically the principle behind filtration. So you have the mixture of insoluble solid in the liquid. You pour this mixture through. The larger insoluble solid particles are trapped by the filter paper in the filter funnel. Small particles of liquid pass through, okay? Now, if I show you another diagram here, okay, this is the example. You need to know this, okay? The words in purple here, residue as well as filtrate. These are important words. So whatever that is trapped in the filter paper, we call it the residue. Okay, this is pronounced as residue. In this particular example, sand is the residue. The liquid that passes through the filter paper, we call it the filtrate. Okay, in this case, the filtrate is water, but it's not going to be water all the time. Sometimes it can be other liquids. It can be solutions. But in this example, I must know how to identify which is the residue, which is the filtrate. Clear? Okay, so this part here is important. Now, another method to separate mixtures will be evaporation to dryness. Okay, so this is actually for us to obtain a soluble solid. Note the purple words again, they are important. So the soluble solid is obtained from the solution by heating the solution until all the water is removed. Example, salt and water. Okay, so this is salt solution. As I heat it, it starts to boil, right? As it starts to boil, the water is actually lost. It will be evaporated. It will be boiled off. So these are the terms you usually use. Yeah. So once the water has been removed, all right, what will happen? The salt will remain as a white residue in the evaporating dish. Okay, you see it like some form of powdery stuff. Okay, like salt powder. You might do this in the science lab. I hope you have a chance to do that. Okay, it's going to be fun, but it's dangerous as well because it's very hot. Okay, you cannot touch the evaporating dish. This is what I see happening in the science lab. Some of my students are so excited, right? Being in Sec 1, they might not be careful, okay, and then they go and touch this evaporating dish. Is extremely hot. Okay, even the tripod stand, you can identify where's the tripod stand, right? This is the tripod stand. Then you also have the wire gauze. All of this you must not touch with your bare hands. Okay, you will actually burn your fingers easily. So substances that decompose on heating, we covered this last lesson also. Substances that decompose on heating cannot be obtained by evaporation to dryness. This is what you must take note of. Not all substances can be obtained this way. Okay, example, sugar decompose on heating. If you were to heat it to dryness, upon drying, you get this black stuff left in your evaporating dish. Okay, this is actually carbon. Okay, so we don't remove sugar from sugar solution in this manner. So what do? We carry out crystallization, right? So crystallization, okay, we can actually get back substances that decompose on heating. You have two examples here, copper sulfate crystal, sodium carbonate crystals. All right, so how do we carry out crystallization? Step 1, Okay, we have this impure copper 2 sulfate solution, right? Then the solution is heated to remove most of the solvent, which is water. Okay, so heating is stopped when a saturated solution is formed. Usually we heat it until half the amount. So we have half the original volume. All right. So then the hot saturated solution is allowed to cool. So what happens? Okay, the dissolved copper 2 sulfate will reappear as pure crystals. In this particular case, it will be blue in color. All right. And then because it's rapid cooling, you only get small crystals. Okay, if you want the big crystals, right? If you take a look in the science lab, sometimes you will see that some students are doing certain experiments. They are growing very big crystals. You know, I have already done this with students before. Okay, yep. So I let my students grow very big crystals. Okay, so they stay back in the afternoon after curriculum time, right? They go to the science lab and they start growing the crystals. So they have to look after that growing part. Okay, the entire process. They have to look after it like a few months. Okay, the longer, okay, you grow the crystal, the bigger it will become. Right? So later, if we do have time, let me show you a video, very interesting video showing you how to actually get big crystals. Right? So the crystals formed are then removed. Okay, sometimes by filtration, sometimes it's easy for us to pour away that solution, okay, that's left behind, right? Then we will wash with a little bit of cold distilled water and then dry it between pieces of filter paper. All right, so this is what happens in crystallization. Okay, so choosing the suitable solvent is important. Okay, and then last lesson, okay, I also send them a piece of homework where they are supposed to, okay, separate two substances. So I have a mixture of, let's say, sodium chloride. Sodium chloride is actually salt. It's the salt that you have in the kitchen. Okay, table salt. So salt and sand, how do they separate it? Okay, so Hein, if you have done your work already, okay, you should know that you are supposed to add water to dissolve the salt, right? Okay, then you get salt solution plus sand. So what do I do next? Next thing to do, filter the mixture. Once you filter the mixture, you're going to get the filtrate, and then you're going to get residue as well. Okay, so what is the filtrate? Filtrate is sodium chloride solution. Remember just now I said filtration, right? Not all the time you get water. So in this particular case, you get the sodium chloride solution. Right? And then what is the residue? Residue will be sand, but of course, you still have tiny traces of the sodium chloride solution there. Okay. And then the next thing you do is, for sodium chloride solution, evaporate to dryness, then you get your sodium chloride, the salt. Okay. Whereas for the residue, the sand, we will rinse with a little bit of distilled water, and that will remove the sodium chloride solution. So you get your sand as well as your salt. Okay, so this is where we stop actually. So now, okay, take note. Today's lesson, we are actually focusing more on, okay, chromatography, distillation. Okay, these two methods. But distillation, there are two types. So what are we doing here? We are actually trying to get back the liquid from a solution. Just now we were getting back the solid. Remember, salt or sugar, copper sulfate. So those are the solids. Now we are trying to get back the liquid from a solution. So how do we do it? All right. So in order to understand a bit better, maybe you can take a look here. Okay. So in order to obtain the solvent from the solution, we are talking about the liquid we want to obtain, right? We carry out simple distillation. Earlier, we were talking about evaporation and crystallization because we want to get back the solid. Now we want to get back the liquid. So what is simple distillation? Okay. Definition will be to separate a pure solvent from a solution. So you have the definition here.